Okay, so you've probably got something that looks like this. I'm going to scooch this around, move mine around just so I can get a little bit more room. So I've got a part like that. It gets revolved. What I think I'm going to do is just add a section onto the back of it. That is 0.5 tab 743. And that way, I'm pretty well good to go. And then I can take and revolve this section and select the axis.
Can't you extrude it from the back of the
So I could also do that. I'll do that one too. So if I wanted to just extend the back of it out, I could. Let me back up a little bit more. So if I wanted to just push this back and go, could probably do it from this section here and go maybe 7. Nope. I need to do a constraint there. So I'm going to delete this. And I'm going to delete this. And then I can draw a line here and just make it 500. And then go from here. See, I'll go ahead and go from here back to here. Draw a line up to here. So I can do it like that as well. And then got something that looks like that.
So we're adding half an inch to the bottom.
Add a ½ inch to the bottom. Yep. So it does make it a little thick. It's a little bottom heavy, but that'll be okay. That'll give us the ability to come in and hold on to this thing as we go. So all we're concerned about is the turning on this thing right now. Everybody's got this, or you're doing this right now? Is anybody not? You're doing that right now?
Yeah.
Okay. Yes.
So when I go back to the first sketch, it's not popping up anymore.
Let me see. Oh, you don't see anything. All right, let me know. Desiree, are you doing this to yours right now? Okay. And Shay, you're working on yours right now.
Yeah, so I did that ½ inch. Should it automatically have a revolve to it?
Depends on how you did it. So if you did a ½ inch chunk on the backside, which is probably how I would have done it originally, you'll have to do that as a separate revolution.
Okay, so I have to extrude it again and everything?
You would need to extrude it or revolve it, yeah. You could also come off of this backside, I guess, and you could do a new face. And then you could push off of it like this.
That's what I did.
So the only disadvantage of doing that is it's no longer part of the revolution. It'll still function for what we're doing. It'll still function just fine. Yeah.
Do I need to delete the line that was in between? That was the original bottom.
Yeah. Yeah. So that's what I did. Is I deleted the original line. I just extended my whole part out ½ inch. You can do it like this, or you can leave your part alone. Create a new ½ inch chunk on the backside. Yeah.
This is just hot topic. When are you guys gonna start carrying the machines over to the?
I That's severely off topic.
Yeah, it is. I was just thinking about how you guys are gonna carry them over, like.
Well, that's what we use students for. You ever seen the Egyptians build the pyramids?
No,
It's gonna be something similar.
So explain that.
Exactly, that's why we have you guys here. Yeah. I don't want to saw stuff. So we've got we're talking to some riggers right now, and so my assumption is that we will use a rigger company for part of it, and I think that we'll probably move part of it ourselves. So it'll be in between if the timeline of everything goes right, which I don't think it will. Just because that's how there's just delays. A 2 week delay by the time we get to the end of things makes a 6 month delay, you know. So my suspicion is that we go through that first semester of next year still here. Then we do all of our moving in the summer. Because that's actually what welding is doing that the year ahead of us. So they're doing it right before us. And so my assumption is that, but if the timeline goes perfect, when you guys leave for holiday at late December, mid-December, the riggers will be here the day after you leave. And we will run rigging all the way across. So they're gonna run it, and this is not how I would do it, but I'm not sure why they wanna do this. They're gonna run 3 semis, and they'll run 2 fork trucks down here, 2 fork trucks up there. We're gonna load 2 on a semi, run it up. Next semi will come in, load 2 on a semi, bring it back around, and just keep looping them until we get everything up in there.
Are we gonna be here to see the new building with the machines
Are you going? Well, that depends. Are you planning to be dead
in?
on another planet
No,
in a different? It depends. I mean, that depends on how fast you graduate. You know, with your grades, you're probably gonna be here. No, I don't know. It just totally depends on. Like, we are supposed to be in that building in class January. That's a short timeline. But I'll tell you, they're moving pretty fast now. They're moving faster than I thought. Like, it took them a long time to get concrete. And once they got concrete, I mean, they've got all the trusses painted. They've got a ton of the classrooms already built. So they're moving faster than I thought. Once the shell gets done, electric, plumbing, networking, all of that stuff, it'll take some time. So you're throwing a dart at a board trying to figure out exactly when it's going to happen. I think, though, depending on how aggressive your schedule is, you'll probably end up with a class at least, or a semester in that building. Would be my suspicion. So it depends. I mean, if you're not an AAS student and you're just a certificate student, then you're probably not going to be over there. You're welcome to come over there afterwards, though. I mean, you're welcome to be like, hey, I graduated. I just want to check the place out. That's totally fine. You know, that's no big deal. Some of the things that we've got coming down the pipeline, and you open the door to the segue here. I've got an agenda I'm trying to push right now. It is a complete cell that has conveyors, robots, robot welders, CNC machines, and industrial design, so EDT, that goes in the welding lab. And every student first semester will come into that, and they will experience design, conveyors, robots, robot welding, machining, design, all of it. You'll have to take a class to help you figure out what you want to do. And so we'll call it an exploration class. So everybody's going to do that first semester, hopefully. Then from there they go on into machining, welding, IEM, EDT. So this whole manufacturing cell, my dream would be that it'd be in the welding lab. Also, we are getting a fab lab that is mini mills, printers, lasers, and a whole bunch of other stuff. It is freaking huge, and it is awesome. Like, we're paying people to come down to just make it awesome. Like $5,000 to just come down and tell us what the dream plan would be, and then they'll help to help with the design and stuff. And then you can pay like a membership fee, like $100 a year or whatever, $50 a year. I don't know what it is. It could be $2 a year. I don't know. and then you'll have full access to that whenever you want. So full access to 3D printers, milling, turning, miniature, and all kinds of other stuff. So the place I went to this summer, Gateway, that's how theirs was. And like people would just come in if you just had a project you wanted to make. They had people there that would help you 3D print it, machine it, do whatever you wanted to. And so that's our dream, is that we would have that. So
So open to the public.
open to the public, yeah. So it's gonna be pretty cool. So when you come up to the four-way here and the hallway, so if you come in these doors or you go through this way, like there's a classroom that has a long stretch of windows. That's where it's gonna go, and we're gonna open up that other section so it's like all glass so people can see in and out of it. So it's gonna be pretty nice. But what's crazy is we just figured out how important manufacturing was. I mean, like, I know we know it, but like the school just figured out, oh my gosh, we've got to be on the cutting edge of all these things, and so we're getting there. I mean, it takes time. There's a lot of cogs, so it just takes time to do all that stuff. So, all right, Desiree, you done?
Yes.
Shay, you done?
Mm-hmm.
Okay, everybody's got something that looks similar to this. Yes.
What's the slot in the pod or the bishop for on the top?
Slot in the bishop.
Yeah, on the circle part.
What's it for?
Yeah, what is that for?
I don't.
It looks like a bottle opener.
Yeah, I don't think it's a bottle opener. I mean, an aluminum bottle opener isn't.
I just didn't know what
Yeah, and those parts are pretty fragile, especially when you get to the king, the cross, and some of his other details, like miniature cuts, man. Like we are going to be taking 8 to 10,000 cuts on some of these things because they're going to be so fragile. I mean, some of that stuff's like an 1/8 inch thickness, super, super small. All right, everybody's got it done. Get to a spot where you're here. We're going to go into manufacturer. I'm just going to delete mine out. I've already got some stuff there. Delete these two things. That way we're all kind of starting in the same spot. So we're going to go to our setup. Setup. And we are going to get this thing set up so that we can be on a lathe. Currently mine is like ultra jacked. Definitely not the right size or shape for it. My Z is backwards. I don't really care so much about stock at this point. Part of my problem is that I haven't really told it what it is that I'm doing yet. So I'm going to go in, I'm going to select a machine. I've got a Haas lathe. And I'm going to do a turning or a mill turn on the primary spindle. Here. So you can go into a couple of different places if you want to go here. I've got some machines already built out for some of these, but you can go into. If you're not running the cloud, then yeah, you can probably go to local, and then you can probably go to lathe. And you can build a lathe from there, or you can go to turning. You could go, let's see, go down to vendors, try to find a Haas lathe. Let's see if it's got anything already set up. Like mine's gonna keep finding the one that I've already built.
Can we just do that one right there? The generic mill turn?
You can do the generic mill turn. It may give us a couple of hiccups as we go because it's got some live tool options on it. So,
that's the only one I could find pop up.
Yeah. And so it will be one that we can definitely play with and get started with. So if I want to go in, I might go in and edit it and just take a look at its dimensions. if you'll notice everything on it is in metric, go ahead and switch it to inch. You want to change it to just do turning, because otherwise it may try to mill some sections out, okay?
That's turning forward.
Yeah, so make sure you're in inch. Kinematics and workpiece shape and design is not going to really be that much of a big deal. Coolant's not going to be a big deal.
How'd you change it?
Down at the bottom where it says millimeters. See where I'm at?
Yeah.
Just change it to inch. And like we only have flood cooling. It's not going to matter, or coolant. It's not going to matter if you have these off or on, because we're just not going to worry about it. Let's see if I can find a processor that's a real simple Haas. Probably like an ST. I want something on my output, or for my post processor, I want something that doesn't have a Y on it. So like ST10 is pretty small. And then I do not want to really do anything into multi-axis, and since I turned my capabilities to just turning, I should be good after that. Because what I don't want it to do is I don't want it to start to try to mill as I'm turning. So I can select that guy. I think I just can flip my Z. But what's that?
What'd you do for the second setup?
For this, I don't have a second setup yet. Did you finish your machine? So finish your machine, and then my setup operation type is turning, primary spindle. I had my orientation on my Z axis, so my Z is going forward.
Mine doesn't look like this.
That's way better. Mine's jacked up right now. Mine's the remnants of a 4th axis program. Yours should look like that. Mine is not right. I'm gonna get caught up as we're going. Your Z, like I'm gonna move mine to so that it goes out to 100 thousandths and everything. I don't really care about the chuck. I'm gonna go back here. Go back and select my model. I need to make my part a little bit longer. 3 inches isn't really going to do that anymore, so I'm going to change my overall length to, I'm just going to make it 4 inches. And I want to make it from the front. My offset from the front, maybe 50 thousandths. Okay, so we all have something that looks pretty similar now. Got about 50,000 stock in front of that thing. I've got 4 inches. My stock is 1.5 inches diameter. Everybody with me on that? Are you there?
I had to flip my Z. Mine was
I had to flip my Z too. Yeah, my Z was going the other direction. And really, it all depends on how you start. Mine was jacked up because what I just deleted was all the 4-axis flute cutting, which I had set from my last previous operation, which is fine. I mean, you can flip back and forth pretty easily.
Offset from the front.
Offset from the front and leave yourself 50 thousandths. That way we can face it off.
So safe Z, is it the?
What's that?
So does safe Z mean like it's all part?
Where are you at?
I'm on the setup,
First tab, second tab, third tab.
first tab.
First tab. Yeah. Z safe or safe Z. Z reference stock front. And then I offset it by 100,000s. I'm going to use offset 54. So go ahead and click onto one. I'm going to go ahead and give it a program number. If everything went really slick for me, which it probably won't, I would just organize this in a labeling system of, 1, 2, 3, 4, 5. That way I could always pull these up. If I decided I wanted to make 10 sets of these, I could probably pull those out and go. So I might start this with program 100, and I'll just put a quick little note in there that says pawn. No multiple work offsets, at least not for this. And then, okay. Go ahead and do file save. I rarely have problems with it, but just to be on the safe side. So on this, what would our normal first operation be on a part like this? So we've got an 1.5-inch diameter stock sticking out this far. We're chucked on it back there. We don't show the chuck right now. We can show the chuck if we want to. What typically, you guys just did a part out there. Which first operation? Face it off. Is that what you want to do here? It's one of those 50-50 kind of things. It's personal preference, really. If you face it off, it's full radius, right? So it doesn't actually, it's not going to be there when you get done because there's no flat on it. You could actually go directly into lineal turning across here. So if you want to face off, you do a singular face pass that it does through there. If you don't want to, you can go straight into turning on the OD. So if I want to do a face cut, there we are. If I want to do a face cut, I can. Go in, I'm going to select the tool. I got a profile tool that I'm going to use. Now, again, if you're not going to face cut, you don't have to do this, but you will still use the same tool. So there's my tool. I can go ahead and set my surface footage. My max spindle speed that's way too high. I want my max spindle speed to max out at 1200. It's going to feed at 12 thousandths per inch. Everything else is doable. Okay, so it's going to come in, and if I want to go simulation, it moves so fast, it just makes it shorter. That's all it does, okay? So I've got it faced off if I want to use that as my face off.
What turning tool are you using?
I'm using let me just go back and pull it up. VBMT 431. So what's the corner radius on a 431? You're gonna need to use, that's why I wanted you to use that tool out to there on the machines today. You're gonna have to use that real kind of high rate profile tool for all of our turning in this one, or on all of these, because there's so much, like in some spots there's some places where you're gonna have some kind of undercuts that you're gonna need to get around. So make sure that your tool is the VBMT 431. Should have a 15 thousandths tool nose radius. If you need to see the details of it, I can pull it up. So 431 has a 1/2 inch inscribed circle. Yeah, thickness of 3/16, corner radius of a 64th.
I don't have any tools.
So if I need a tool, I can go to my Fusion library. I can go all the way down to sample turning tools. Do you have tools and sample turning tools? Another way that you can do it, you can filter it over on the right hand side, hit turning. And then you can kind of work it down this general turning. So you don't care about boring, you don't care about turning grooving, and you don't typically right now care about turning threading. I made some parts the other day for our esports arena, and I did like I was just super lazy. I did not want to do a whole bunch of tool changes. I wrote the entire turning path with the parting tool. So I faced it, turned it, and parted it off all with the turning tool. Or with all with the parting tool. So I was like, I just don't want to deal with it. So hit go, walked away, came back, like, sweet. It's not the best way to do it, but you can turn with the grooving tool. BBMT. So it's a pretty sharp profiling tool.
Can you go to the insert?
Yeah. Let me go back to. There you go. So 35-degree diamond, 0 on the relief angle. Oh, I said BBMT, I meant BNMT. This will then be, really for most of what we do, we'll be able to do most of our turning with this tool and most of our parting with the standard part off tool that we have.
How about change these from metric?
You're the bottom.
Yep, so go down to units.
Where is that?
I'm rethinking some of my projects because of the. It's good for a. If you don't learn file control in 101, you will struggle with file control for the rest of what you do. So it's really important. Like I already saw a lot of this going on out there, and so you end up with that curved surface on the top there instead of going like this, picking it up, going like this, picking it up. So a lot of this happening, and they will get it as they go. All right, everybody got that insert design?
What's the corner radius?
1/64. So 431 is a 1/2 inch, a 3/16 thickness, and a 64th radius.
I still don't have any tools.
Bring it over here. Sample. Here's one that's gonna be really close. I would just take this tool, edit it, insert. Come back and edit it. Now you can edit from there. Like I said, two primary turning tools that we're going to be using on these. That's the V&MT, and then that's the 1/8 inch carbide, or 1/8 inch parting grooving insert that we have. That should take care of probably 95% of our turning. So once Mikhail's caught, everybody else has got that tool correct.
Mhm.
If you want to go ahead and start working on your parting tool, you can do that as well. It's going to be just a normal parting grooving tool.
How do you save this tool to your library?
Once you hit accept,
Yeah.
So like I created a cloud so that, or under cloud, I created one that's called SFCC tools. And so I just created a folder there. And then that way, if you're doing it in cloud, if you use my laptop when you're home, then everything's on there. If you use a different laptop, then it's still on there because it's accessing it by the cloud. If you create your tools as local, they're only going to be on that computer. So if you're working on, so like Mikhail has his computer here, and if one day he forgets it and he has to use one of my computers, his tools will all be gone. And so he'll have to create new tools for it. So if you do it by cloud, since Fusion has the base of a cloud, then you're going to be able to use those tools wherever you are, whatever computer that you want.
Can you show us some specs on the parting tool?
I have mine set as 2 and 4. That's just because I normally use a WNMG or a CNMG as my first tool. But you can change this to 1 and 4 if you want to. We'll keep the parting tool at 4, but you can use it 2 and 4, 1 and 4. Doesn't make any difference.
So it would be a ID grooving, right?
No. OD.
OD.
Yeah. ID would be like an internal, like a groove in a bore. Okay, you got both those tools set? Okay. Anybody doing anything exciting this weekend? Nothing? We went down and did our last float trip of the year, and we were unknowingly, my brother and his family were like 20 minutes ahead of us the entire day. So we get back and we were talking to them later on that day, and he's like, yeah, we were down at NRO today, and we're like, we were too. What time were you down there? He's like, oh, it's like 10:30. It's like, we were there like 10:45. So kind of weird. Shade, you get yours set up so you're saving to the cloud.
Yeah, I think so.
Okay.
What's that on the corner there?
Corner corner radius is 32 thousandths. And really for most of what we do, corner radius is gonna be somewhat insignificant, but I think I would put a corner radius in there because I wouldn't want to design it as completely square 90-degree tool. It's somewhere, honestly, it's probably somewhere closer on average to about 20 thousandths because we alternate between a couple of different parting grooving tools, but that should cover everything. All right, everybody's got all both of these?
Yep.
Cool. Okay, so that's my tool. I'm gonna use a flood coolant on it. My surface speed. What do we think our surface speed should be for aluminum with a carbide insert? 5,000 surface footage.
Just 370.
Yeah.
400?
Oh, you're talking about the surface speed?
Yeah.
Oh, mine says 300. If I had my book, I would have.
By now you should be starting to know these things because we've been in aluminum for a long time.
I think 1200.
For surface footage
Yeah,
or for RPM?
RPM.
If we go by surface footage, then we won't have to worry about RPM. So if we say, hey, we want to be between 600 to 800 surface footage, then our speed will adjust to that. So we won't have to be continuously calculating RPM. Because and why that's important is because where the tool is at multiple diameters. At this point, it's at 0 diameter. At this point, it's at 1.5 diameter. Then it's at 1 inch. So it's moving through there. That's why we need that spindle to speed up and slow down so everything stays consistent.
I got 1500.
1500 RPM.
No, 1500 for the surface speed.
Okay, that's probably a little high. Let's try it at 1,000.
I put the diameter at 2 inches. I'm not sure what it actually is.
It won't matter. The diameter of stock is 1.5 inches. Surface finish or surface footage doesn't really. Once it's at that surface footage, it's gonna stay there no matter what the diameter is. Okay, so let's set it at 1,000. We'll max our spindle so that they don't go over 1,200. We can use feet per revolution or we can use feet per inch. We want to use feet per revolution. So on this tool, for everything other than our finished cuts, 12 thousandths is a pretty good feed rate. So every time the spindle spins 1 revolution, the tool advances 12 thousandths. Second tab, I'm at model front, offset 0. Here, I could probably, depending on how much time I want to spend on it, I could probably tweak some of these down pretty close. And I think it's probably worth spending a little bit of time making sure that those things are going. You're going to keep yourself from doing some air cuts. I oftentimes will go down to like about 100 thousandths. Oops, there's me decimal points. I just want to bring it in a lot tighter. Otherwise, you're going to end up rapiding to 3 inches, 2 inches, 1.5 inches, and it's going to just like lots of steps getting down to it. This way, we can get down to something that's much closer to what we want. Our tolerance.
But you need a back percent.
Yep.
My offsets and stuff later.
Okay. And they can be different. This will not affect. Okay, this will not affect profile of part. It's just rapid zones around the part. I set my tolerance to 10 thousandths, And then I've got my compensation as set for in computer, and then if I wanna leave stock, I can, come in and take a finish pass. Let's go ahead and do that. Need you to remind me that we are leaving stock in it though.
So are we not doing anywhere
On the last tab?
on
Or-
the compensation?
No, so like we did that on the mill, no, we'll do it here because we'll do our cutter compensation slightly different here. So we can just let it do the computer. But yeah, where on the mill, typically where compensation was our standard compensation. And then we can do full retract. Everything else here is pretty standard as far as in and out movements.
Can you go back to your offset page real quick?
This offset,
Or no,
stock offset.
yeah, there you go. Mine, I have everything the same as you, mine doesn't look like that. Mine are all like in the middle of the park, instead of all outside.
Is your retract set to stock OD?
No, it's like a stock ID.
Yeah, that's what I bet all of yours is set to. So your first one should just be for retract, stock OD, stock OD, and stock OD. Everything that we're doing is an external diameter at this point. So I was still on face. So you've got your tool set up. So were you on face as well, or were you on turning diameter? Okay. So all of those things should remain the same. I'm going to go to turning diameter. My tool pulled up the same. I'm at the same surface footage. I'm going to max my RPM at 1200 again. My 12,000 stayed the same. Everything else, I do have to do some quick adjustments there. And so now I've got my profile.
We're doing the roughing one, not the finish.
Yeah, I do the roughing one. If you want to keep the finish or the face pass, you're welcome to keep the face pass. If you decide, I think I can do without the face pass, you can definitely take the face pass out. If you wanna, then you need to go to profile. I'm accidentally making more profiles. So you could have a face and a profile, or just simply a profile. You can't just have a face. So I'm looking at mine, and I see, okay, so that must just be on the last pass. Because that groove is not very big. Go back and look at something. All right, so on my OD, stock to leave, I'm gonna leave 10,000s radial. And I really, axial stock, I could be a 0, I'll be okay with that.
Hold on.
Yeah, I'll come back. What do you want to see? Okay. So I did stock to leave 10,000s.
What do you do if it says empty,
Toolpath.
Yeah.
I would go back. See if you can check this on the second tab. See if you check model, if it'll find it.
So on the stock to leave, mine says X stock to leave and Z stock to leave.
It says what?
X stock to leave and Z stock to leave.
Okay, yours might be
it says
like,
no model contour.
okay. Bring it up here. So Shay, you said that yours says on stock to leave X and Z.
Mm-hmm.
You might just have a different standby. Like mine just says similar to what it said on the mill side. So radial stock is X, and then axial stock is Z. So your face though. Let's see what it looks like in simulation. Nope. Oh yeah, it did. Okay. Now let's take a look at this. Yeah, should be alright. Hold on.
I mean, which? Oh, this one? You looking for what?
Just to see. Is it weird that it's trying to go inside those grooves?
Yeah, that's where our problem is. So let's see if we can just fix that.
It's probably not right.
Let's see if I can get a hold of just. I want that 2D. Try and grab. Let's do this. Two axes. Oh, yours says stock to leave an X and Z as well. I probably need to update mine. So I'm gonna go back and look at your model real quick. I'll make it to where we can only see it. Hide that profile. Now let's go back to manufacturer. So now we've got the profile there. Let's go back here. Nope, going back again. Alright. This is what I want.
So it is letting the fox go and start cleaning it up. Just go back and double again everywhere. And then once you get it, you can get it. Justin, you care about them coming to the chef?
Go for it.
Alright. Yes.
I'm gonna look at your folder as well. That section right there is just gonna be a hard section. we're gonna have to come back to this. You're gonna need to break that apart. So here's where the problem comes in, is that, let me go back and fit it in here. It's on the line rotationally that hits this, and so it goes to whatever it can, and it just happens to grab this low section. It really needs to be clocked just a little bit so it can get through here rather than there. Hey, does anybody else have theirs going through the valleys of those?
Yes.
You do?
Yeah.
You do not, you guys do not though?
No.
Okay,
I know exactly what.
you know what's wrong? Yeah,
It's because I didn't do it on the front side, I did it on this side, so they're all just a little bit.
yeah. Yeah, if you're,
I simulated it and
it did the exact same thing his did, is it went down into, let's just see if maybe. So yours did the toolpath, it just didn't quite select it, so you might not have quite as big of a problem as he has. So let's do this, let's go back and see if we can grab model. Let's see if we can just select on these. Might be able to just grab.
Yeah.
Let's see if we can turn some of that stuff off. I mean, invisible. I do. Try and hide all that if I can.
so is it something I'm gonna mess up in drawing?
Yeah, what you really, you have your rotation, so your rotation needs to go, like, when you see it, it needs your center line caught in the middle of a valley. Right, it'd be better if it was rotated the other way, that way you can catch the diameter of it. We might still be able to get it though.
I gotta make that.
No. It took like, probably like an hour and a half for me to make it.
Yeah, cause he like actually showed you how to make the pedestal, and then
Just fast forward.
fast forward it, so I'm like,
Yeah, you gotta hand like draw a line.
what I'm doing today.
Okay, so
I have pedestal down.
we might go to,
You've done it.
I've done pedestal. I started with that.
Do you embrace it too?
I already did all the immersive. These two then.
got the same problem. You're gonna get those valleys. You can get this section there, that's good. You get that. You're not gonna be able to get these freaking idiots. That's gonna be a bear.
No, there's no top.
Okay. So here's what I want you to do. Do you need here? Okay.
Just have a question. Where you get a second?
Yes.
Start for her.
So you don't have the exam.
You wanna wait till,
We're gonna have to catch them up later.
okay,
Shay's in the same spot.
right,
so-
you got one other, so.
Yeah, we're gonna catch, we'll have to catch them up later. So we'll just run it separately for them
That works.
after the semester gets
Okay.
moving.
We'll worry about that later on then.
Alright, so let's go back to design.
It's fine, guys, if you're done, you can go.
And
You're recording this class, right?
Uh-huh.
Okay. Where would we find this at? The video recording?
here's what I'm gonna do for you right now. So we're gonna do this. We're gonna go file, save as, on, turning, and then we're gonna delete this. Okay. So now I'm gonna go back to manufacturing. And now I'm gonna go back to
We did,
Videos.
the stare at and snap-on.
so now we should be able to catch it.
We did the NC3. That's pretty easy. We did the certifications. So you have to, 6 certifications. It's actually not that bad.
Okay. Redo it now. It no longer sees that. So redo your toolpath for the OD and you'll be good to go.
It's not gonna have the original, though, huh?
Exactly.
It's still that the grooves are still there. I just saved them as another name. We'll just import them back in. Yeah.
I know you don't wanna see me poke. Who's raised this? So.
Yeah.
The basin with you. I tried to do that.
Why do you have a hold one on the back of it?
I think you're pretty good.
I don't really need this class. I have metrology after this, so I just stay here the whole time.
I don't know what you got. How did you draw this as sections or did you revolve this?
Revolve it. Just like you.
I'm not sure why it's grabbing. Hey, Clint, Justin back there is having some problems with micrometer.
Right.
Would you take a couple minutes and help him with that? Okay. Here's what I'm gonna say.